All right. Okay, so technology is sorted, and we are streaming the lecture. So, welcome. My name is Mariusz Nowostawski. I'm originally from Poland, and I've been to Norway for the last 5 years, and I will be one of the lecturers for this course, cloud computing. The other lecturer is Christopher. Christopher is currently on a conference in Sweden, so he cannot be here. And I have to make this a little bit shorter. We have scheduled it for 2 hours, but Christopher's wife is about to give birth, and we have to take her to a hospital at 4 o'clock. So I will have to cycle home to pick up a car and pick her up. So I will finish the lecture at about 3 o'clock. If we don't finish the whole thing, then we continue on Friday. The lecture has 2 slots. It has the Friday slot, if I'm not mistaken, and today. Sometimes we will do practical things on one of those days. Sometimes we do theoretical things in those 2 days. So I will like you to come for both and bring your laptops with you for both. Sometimes we have half of the class lecture-like, we talk, and then the other half we do some practical things. So bring laptops every single session. And I cannot tell you which one is a lecture, which one is the lab, because they are mixed. And we try to mix it, so not to have it boring that I'm talking here for an hour and everybody falls asleep after half an hour. So we try to cut it into kind of a practical sessions and a little bit of talking in between. So that's about the overall structure of the course. As I said, Christopher is the second lecturer. We kind of share half and half most of the course, but we usually come together. I spent some time in New Zealand, so I'm kind of partially New Zealander. I lived there for 15 years and 25 years in Poland, so kind of split personality. Same with Christopher. I met Christopher in New Zealand, so he came here last year from New Zealand as well. We're teaching this course for the second time. So first year, it went reasonably okay. There were small things that we have to fix. So we're hoping this year it will be a little bit smoother. But expect it's not a course that is fixed for the last 10 years and we're doing the same material. Material changes. We have to adapt to the changes. Some things that we used last year may not work this year. So it is a little bit work in progress. So we expect things to be a little bit rough. So, different software packages, different dependencies, different things that we've used might be different and things might be slightly different. So some of the material that we have, we try to update on a regular basis to the new versions. But sometimes we tell you, okay, install this, and, it may not work the same way as last year. So just let us know. Or, we will fix it as we go. One important thing also is that because the area is new and the area is moving, it's not something that is not like mathematics that we have it as given and we have to teach you, right? We're learning together some things. Some things we've learned last year because I've done this course back in New Zealand and some things were different. So we have to learn some new things last year as well. So be open-minded. Make it more of a dialogue and be responsible for your own learning. So, show initiative and read stuff yourself and don't expect us to be the active ones and you be the passive ones. You have to participate. So as I said, we have 2 parts. We have the theory parts and the lecture, so theory and lectures, and we have the practical kind of labs. So the theory is usually us talking. Sometimes we have some quizzes, sometimes we will have some discussions. In some other courses, other teachers were using team-based learning where we give you some tasks to work in a group, and that's a form of learning as well. So we will try those. And then the practical sessions are split in 2 bits. One bit is you kind of do your homework. So we give you 3 assignments that you have to finish during the course of the semester. And we have some labs And the labs you don't get grade for, but we want you to do them so they prepare you for doing the assignments, right? So we will have 3 assignments that you have to do, and you do it in your own time or during the lab sessions. And we have labs, which are kind of a practical tasks that you do in a group or individually, and you just do it for yourself. So they are not graded and they are not marked, but you can show us what you've done and we can help you to improve it or to fix problems if you cannot solve it. So what is this course about? What is cloud technology? How many cloud services have you used today? Any ideas? Way too many, yeah? So what have you used, yeah? Google Drive, yeah?
OneDrive, Dropbox.
Yeah. What else? Those are cloud services for storage. Yeah? GitHub, yeah. What? Yeah.
It's the new NVIDIA game streaming thing.
Steam or what? No, I don't know that one. Yeah.
They do it on the cloud, so you basically use another.
Yeah. So you run it and then they stream the video processing. So they process the video in the cloud and you get just the final rendered images. Yes. Yeah. Gmail, cloud's app as well. So why do we use it? Why do we migrate it from services that are not in the cloud into the cloud? What are the main benefits? Yeah.
Distributed, or your work is not on you, so you have access from anywhere.
So from the user perspective, it's easier to work with such services because you can access them from home, from work, from laptop, from your mobile. You're sort of device independent. So they blur the boundary of how can you access the content that you want. What else? What else is appealing? Yeah.
You have like a safe backup. A lot of those big companies have like backup of your files as well.
Exactly.
Some companies have like their flat burned down and then they lost all their data.
So it's a robustness. So you sort of shield it from hardware failures, right? So you don't care if somebody else's disk crashes or whatever because you know they have backups and they will recover it, right? Which is kind of surprising because I have a story, like how many of you used Amazon Cloud for instances? So Amazon is like a big provider for cloud computing, right? So you can order an instance, which is like a virtual machine, which is like a virtual computer which runs in the cloud, and then you can use it. So first time I ordered an instance, then I've used it, and I had some web server there and so on. And after like a year, they emailed me saying, we had some hardware failure, and now you have to move your stuff somewhere else because in 2 weeks, we're gonna shut down that machine. I said, really? I have to do it? I have to migrate my stuff? I thought, it's automated. It's gonna happen automatically. I don't want to hear anything about hardware, right? I don't care if your hardware failed. I just want my VM to keep running. But you have to manage it yourself in a way. They have some sort of provisioning and so on, but you kind of are responsible for your own migration of hardware that failed on the account. All right, so coming back to learning, yeah, the slide seems to be a little bit out of order. So this is what I talked about, you being involved in studying and learning together with us. So there is this theory on blended learning that the theory says that we cannot really teach you anything. We can help you to teach them yourself, right? You have to teach yourself the new things that you need to know. And you need to be able to communicate with others, so discuss your ideas and communicate what you already know. You have to take control over your own learning, so set up your own goals and set up your own things that you still don't know. You have to be prepared to learn beyond the course, right? So of course we have a semester, we will learn some things, but things will move on. And then next year, if you want to do something with the cloud technologies, with the cloud services, they will be different. might be different languages, might be different services, might be different APIs. You'll have to learn again, right? So the act, like we mostly focusing on the learning how to learn, because we cannot teach you everything that you will need in your life. We can only teach you some bits, and then you will have to keep learning as you move along. So the bottom line is that we will kind of experiment. It will be more of a discussion, more of a working together, and you are responsible for your own learning. So if you fail, it's not like we failed, you failed, right? It's like a gym. Like if you buy a gym membership and you don't show up, you will not get fit, right? You have to show up and you have to train. Then you will get fit. Just buying the membership and having the member card will not give you anything. Same as here. Signing up for the course and me talking to you will not give you anything if you don't put in the work. So that's about it. We have to focus on the learning outcomes. Yeah, those are kind of a little bit boring bits. We can change the way how we go about it. So what we want you to learn. We want you to have strong networking foundations, right? Unfortunately, the degrees are organized a little bit in various tracks in such a way that some of you have more or less networking background. So in this course, we will kind of go over some of the networking basics. We need to know how the data centers work, what are the differences between SaaS, PaaS, and infrastructure as a service, what are the implications of doing services in the cloud, what are the privacy considerations, and so on, what are the legal implications, and maybe what are the social ones as well, like what does it mean that the data gets aggregated? What does it mean to us as a society that, you know, Google knows a lot about everybody because they can, I mean, they're not spying on us, but they still have access to raw data and so on. It is kind of interesting. I've read a short article because each country, they have some taboo topics. And how we know those taboo topics, because Google knows who searches for those topics in particular countries. For example, okay, I will not go there, but there are some different taboo topics in different countries, and you can kind of Google it, and you can get the list of what different countries are kind of asking in secrecy of their own home about something that they want to know, but it's awkward to ask their friends about, right? So it has kind of a social implication that you may not think about, but having those kind of aggregated data centers provides some kind of nuanced insights into some of those social things. And then there is the list of skills that we will kind of try to achieve in the course as well. All right, so I'm kind of rushing a little bit because, you know, of the baby. There is a questionnaire which I would like you to fill in, but you didn't know to bring your laptop, so do that at home. The URL is there. There is the URL for the last year one, and I have the results from last year just to give you some insights why we're doing it. So we will kind of, it's just a survey like of what you know, what you don't, right? So last year when we asked students, only one person said that they knew Go programming language. And that was the distribution for different programming languages that the class kind of represented. So we're kind of interested how it changes from year to year, and what sort of skills you come here with, and what you will kind of go with after the course. How many people use different version control systems, preferred IDEs, and so on and so on. So you can browse the responses because the URL is there, so you can see. I think you can see what other people said last year. And please fill in the questionnaire for this year. What you will need for this course? You will need a laptop, and we will install a number of things on those laptops. I haven't. Because Christopher is away this week, I haven't had a chat with him exactly how we're gonna do it. Last year we had people using Macs, we had people using Windows, we had people using Linux. We had people using Windows with Linux and VMs, and we had people using Windows with the bash shell installed, so they could run some limited services, Linux services on Windows directly. That turned out to be a bit crap last year. We allowed everybody to do whatever they wanted, and it turned out to be a lot of work for us because students had a lot of questions, right? So Christopher had some ideas of how to standardize things. So I will tell you on Friday exactly what will be the kind of a default stack. If you're using Linux or if you're using Mac, you're fine. You don't need to do anything special. You just install the software that you need to install, and then you will kind of keep running. If you're using Windows, Windows is a little bit limited in terms of kind of a networking services and so on. So we have to go around it. And I think we will go around it by having a VM image that we will use with the pre-installed software on it. And then it will kind of give you the platform to work with the software that you need to work with this course. As I said, we will have 3 assignments, and the first one will be individual, and then the following 2 will be group assignments. So you will do them together with 1 or 2 other students. If you want to have groups bigger than 3, you have to make a case for it. We prefer groups 2 or 3. And tutorials, as I said, those tutorials or labs are kind of individual or group, doesn't matter. They are not marked. So you kind of do them only as a prerequisite for doing the assignments. The assignments build on top of the labs. So if you've done the labs leading to the assignment, there is very little work that you have to do to finish the assignment because they are sort of structured in such a way that they are building blocks for the assignment, with the exception of the final one. The final one is a little bit bigger, and it requires kind of a plug and play of different components from the labs that we've done. Okay, break, no break. So there is a video. Again, I will not play it. You can watch it at home. It's a 6 minutes video introducing cloud computing as a concept. But instead of watching it, we can kind of discuss it a little bit. So we discussed that you've used cloud computing, but how would you define kind of a cloud computing? We've discussed why we're doing it already, but what is it exactly? How would you define it? What are the properties that you can say, oh yeah, that service is a cloud service?
It is on a network.
Okay, so network is one of the prerequisites. What else? Yep. Yes, so it's someone else's computers, not yours, which is sort of a defining factor, right? So you could say that it abstracts away dealing with hardware to a certain extent, right? You don't have to deal with the CPUs, physical CPUs. You don't have to deal with physical hard drives. You don't have to deal with physical cables. It's somebody else's infrastructure connected via network, and you can access it via the network, right? So as we discussed, it's someone else is doing some work for you. So someone else deals with the hardware, someone else deals with the cables, with the hard drives, and so on. And you don't need to touch the hardware. Like, it's someone else's job to do that. The other thing is you typically have either no costs because you're using services that benefit from data that you're providing them, like Facebook or Google. And then it's kind of free for the consumers. Or if you're a business and you're using Google Cloud services or Amazon, you kind of pay as you go. So you don't have a huge upfront costs to set up a big server farm yourself. You can only pay for what you need. So that's another kind of distinguishing feature of cloud services, that they typically offer you elasticity in terms of payments. And also they offer you elasticity in terms of resources. So very often let's say you have an idea for a small game or some small app, and you need a backend, and you set up a small server, and then the app becomes popular, and the small server is, you know, insufficient anymore. So then you buy 10 new servers, and then year passes, and the app becomes not that popular, and then the 10 servers are kind of not being used. So scaling up and down with physical hardware and physical infrastructure is costly and very time-consuming, whereas with cloud services, you can easily scale up and down depending on the demand. In some cases, that is done for you by the service provider. So depending on the usage and the requests that are coming to, let's say, your backend server, the infrastructure can scale up and down. So elasticity is another element that we use. So what sort of technology do we need to make cloud computing possible? So networking is mentioned. So we need network. What else technically do we need to have a cloud services? Yeah? We need servers. Yeah?
Reliable encryption.
Okay, so we need encryption and servers. Encryption, true, but we could do cloud without encryption. It wouldn't be just safe, right? So it would kind of work, but in an unsafe way, right? So it's possible with servers. What do we need? What is specific about servers that makes cloud services possible? So normal servers, let's say you have a website and you need a server to serve that website, right? How would that be different to having a cloud service? Yeah?
Server would be a virtual box.
Virtualization, right? So that's the keyword. Being able to run multiple things on hardware, share the infrastructure, share the routers or networking stack, right? So sharing from the provider's point of view and from the consumer's point of view is fundamental. And for sharing to occur, you need virtualization, right? So we basically need those two, right? That kind of boils down to those two requirements. Networking, of course, because we have to be able to access those services. And from the provider's point of view, they need to be able to virtualize whatever hardware they have. So the servers, sure, but they have to be virtualized, right? So those are the two kind of fundamental technologies which make cloud computing possible. And then virtualization is a topic on its own. We will spend some time later discussing various virtualization technologies and various ways of how things can be virtualized. But it's the computing hardware, and we mean here CPUs and RAM mostly, right? Networking, we need to be able to virtualize network stack as well, and storage. Some of you mentioned Google Drive and so on. So those are sort of user-centric ways of virtualizing storage. Like you actually don't care how things are stored. You can access them and you can save things, right? The interesting thing about networking is that there was a big shift over the last, let's say, 10 years from physical infrastructure to virtualized infrastructure. So the biggest kind of a manufacturer of routers and networking stack equipment is Cisco. And Cisco relied on racks and on the kind of physical devices that you put into racks, and then they do different things for you. They do packet filtering, they do routing, they can do packet switching and so on. But they were kind of all physical. And the benefit for Cisco was that they were supporting those physical devices, and they were supporting the maintenance of it and the installation and so on. It's a huge, ecosystem. And now imagine that you are kind of an owner of a big data center, and you have those expensive racks from Cisco that you have to update and maintain and so on, right? Wouldn't it be better if you could have off-the-shelf computing, racks that you can buy from any vendor and have all those networking logic done in software? Of course it would be better. First of all, it would be easier to configure because everything you could script, you could configure the network kind of by programming. And second of all, the commodity hardware is much cheaper because you can buy it from any vendor, so there is more competition. You don't need to go to Cisco to buy it, right? And there was this transition. So over the last 10 years, you could see that the virtualized networking became a huge topic, and Intel and other vendors invested a lot of money, and they kind of benefited from it because virtualized networking is the current state of affair. In data centers, you only in special circumstances require specific specialized hardware. You rather invest in commodity hardware and have specialist software doing all the logic for you. Okay, so there are also two perspectives on the course, right? We had long discussions with Christopher and other lecturers on what this course should focus on. And we have two kind of tracks. We have the students who are doing security, and they have a DevOps kind of track, more or less. And we have the Bachelor in Programming, which are focusing on programming. And those are kind of two perspectives that we try to merge in this course, which is not easy. One is that you need administration support and planning and architecting of how the web and cloud services are organized and how they are managed and how they make it possible for it to work for the programmers, right? So how is the infrastructure laid out? How is it hierarchically organized? Where do you put different elements? How you do encryption? How you do security? How do you provision jobs? How you make sure that one job will not suffocate everybody else's tasks and so on. So, you know, focus on virtualization, on configuration management, deployment, scripting, running stuff, how to make it operate and run efficiently and well. The other perspective is that you are the user of that infrastructure. You are the programmer. You provide both the cloud services as well as the services built on top of cloud services. So you don't really run the things. You build them and deploy them, and then somebody else takes care of how to run it, right? So that's the programmer's perspective. And in this course, we kind of try to do both. So with this perspective, you will be programming mostly in C or in Bash or in some sort of scripting language. With this perspective, you would be programming in kind of application development language like Go or Java or some high-level language that allows you to build services and applications. So my heart is more with this perspective. Christopher's heart is more with this perspective, right? So we will be pulling you in both those directions. Christopher will be trying to pull you more into the management of things, and I will be saying, that's not important. Let's focus on programming, on how to use those services, how to build services. Somebody, you know, once you have it, you just say git push, and then it will be deployed in the cloud magically. Somehow it will work on thousands of computers. But somebody has to do that, right? So we kind of complement each other with those two perspectives. And you at heart will love one or the other more, for sure. So you will see how it goes. You will get a bit of a taste of both. Because the course is only for one semester, and because there is a lot of information that we have to do, and there also is a lot of scaffolding that we have to do, because you all are not at the same level at the moment. You, as I said, you have different backgrounds, you have different programming backgrounds, and you have different networking backgrounds. So you're not starting from the flat sort of level. We have to kind of refresh some of the material. So we spent a couple of first lectures kind of getting some of you up to speed. So for some of you, we'll be repeating something that you already know, but this is something others don't know. And for some of you, you know, it will be new, and for some it will be old. And after that, we can start with the course proper. And by then, we don't have enough time to do a very thorough job with either of those perspectives. So the course is really kind of an introduction to cloud computing. If you really want to take it further, you would have to study more on your own because we cannot cramp everything into a single semester. So there will be a lot of things that we cannot do in a single semester. We've been discussing with the administration and with the course boards of possibility of having a continuation of this course, having kind of a Cloud 2, which would take some more advanced topics, and then it would be easier to cover more interesting things and more sort of complex scenarios. But at the moment, we don't have it. So that's the course we have, and that's the time we have for the course. Okay, so for programming, as I said, we will be developing cloud services and deploying them. For deployment, we will be using local infrastructure, the Sky High, the cloud computing facility that we have on campus, as well as we will be using some remote facilities. Last year, we've used Heroku and Google App Engine and Google Compute. We haven't used Amazon. We were planning to instead of using Google Compute, use Amazon this year. And for Google App Engine, we will see. Heroku was kind of similar. So Christopher was arguing that maybe we don't do App Engine. I will tell you next session what the final decisions are and what sort of software do you need to install. And then, so developing your own services and using some vendor APIs. We try to hunt for some interesting scenarios and some interesting use cases. Last year, we used chatbot APIs for doing kind of a dialogue-like interfaces, where you could have a web service where you can chat about certain things with the bot. That API got bought by Google, and there was some changes. We may use it this year again. If you have some ideas, then you can email me or Christopher, and we can incorporate it into the course. We've used some financial services APIs. We've used some GIS services. In the master's level, we're using some of the, I'm a keen paraglider, so I like gliding and doing all the stuff with the thermals data. So we're gonna use some of that in the master's course. We could use it here as well. So there is a lot. There is a lot of fitness trackers with some data being available. So we will see. The idea here is that we kind of use an existing data sources and try to do some mashups or try to do something by combining the streams or the data sources. Okay, so homework for this week. Remember to always bring your laptop for those sessions. Think what you want to achieve in this course. Fill up the questionnaire of where that helps us to guide to plan of what you already know and what we need to put into the course material. And I always emphasize that for any programming courses that we have, that the best way to learn new stuff is to come up with your own project. Of course, you will have assignments. Of course, you will have to do it, but it will feel like work. Okay, so you will do it, and then you will kind of don't want to do it anymore. But if you have something that you want to do yourself, if you have a kind of a pet project, it doesn't feel like work. It feels like fun. You're kind of spending your free time on it because it's a fun project, right? So I kind of encourage you to come up with some small or big pet projects that relate to cloud services or to programming in Go or programming in general or building some simple web service for your sister or whatever, right? Come up with something and then spend some time on it. Use Go to do some little things with it and so on. It will really push you along. So I encourage you to have something alongside the course that is related to the course, and then you use it. You can later on, you can use it as a starting point for your bachelor thesis, or you can make it bigger project, later on as well. And we're really happy to help you, right? So if you have questions related to your pet projects, or if you have some questions of how to do it better or whatever, then we will help you as well. So never hesitate to ask me or Christopher anything, even if it doesn't relate to the course, but relates to the pet projects that you have. Right, excellent. I kind of rushed a little bit, so my apologies for that. One thing is that all the lectures and all the sessions are streamed, with the exception of some of the hands-on stuff. So like if we have kind of a heavy lab that we kind of walk around and explain things in the groups, of course we don't stream it because that doesn't make sense. But every time we have some sort of a lecture, like material or anything like this, we will stream it and it will be available on the YouTube channel. Some of you already have been in courses with me and Christopher, and you have an account on GitLab. If you don't have an account on GitLab, then go to prod3. So the URL is prod3.imt.no and register yourself. On the homepage, you will have, yeah, I'm logged in, so I don't see the homepage, but if I log out, you will see something like this, and then you can register. When you register, use something that we can find you by, okay? So use your real name or your real student ID, something that kind of associates the account with you so we know who you are. We don't let people, because it's an open system, like anybody really can register, so we don't allow people who we don't know into the courses. So please use something real that we can find out. And then I will add you to the group, and you will be able to access the wiki and access the issue tracker. And we only use Blackboard occasionally for some announcements. Most of that stuff will be happening through the GitLab. We've used Blackboard before, and it's really terrible as a communication tool between the students and the lecturers. It's really difficult to follow discussions and so on, so we kind of abandoned it. It's much easier to follow up the discussions in the issue tracker here, and also have the wiki kind of organizing the material for us. So we use that instead of Blackboard. This doesn't have an announcement, so you have to kind of actively look for new stuff. That's why for some important announcements, we still use email distribution channel through Blackboard. But other than that, there will be no information on Blackboard. And this one requires you to use a new registration. It is not linked, even though it's hosted locally and on campus, it's not linked to the your student IDs or anything. So you have to register a new user. The IT was telling us that this domain hic.no will be deprecated at some point, and we'll have to change it to ntnu.no at some point. But we haven't done that yet, so I don't know. I mean, hopefully this will stay until the end of semester. But if they force us to change it, then I will let you know that the domain name changed and the service is stored on a different domain. But other than that, that's all from me. Any questions?
Yes.
Yep.
You mentioned that networking wasn't that well on Windows.
Yep.
What would you suggest us get?
So I will tell you after I discuss with Christopher. I'm personally a Linux and Mac user, and he's the Windows user. So he takes care of all the Windows support, and I take care of all the Mac and Linux support. And I was kind of really happy last year, and he wasn't. So it's kind of up to him. So I don't want to decide something today without checking with him. Right. So he will decide what is the best way to do the Windows things. Yeah. All right. Yeah. Yeah.
Where will the slides be available?
The slides will be available on the wiki on Prod3. Yeah. Yes?
Do we not need a textbook?
There is no textbook. If we want you to read something, it will be specified in the lecture materials with the URL to what you should read. Yeah. Some of the topics are a little bit theoretical, and for those we could use a textbook, but we rather have you understand the concepts than study the textbook. So we do that through discussions most of the time. And the rest is practical, and then some online tutorials and some online technical specs are what we need to read. Yeah. Any other questions? If you have any comments or any suggestions, never hesitate to tell me or Christopher. You have to select a class rep. Yeah, you know the drill. I mean, you've been in classes before. Small difference that we do in our courses is that we sometimes get feedback like in the lecture class, and then we say we had a meeting with the student reps because we already got the feedback, okay? So we don't sometimes allocate a separate time slot for meeting with the student reps we kind of do that like for 10 minutes in the beginning of the class. But anyway, you know, besides the process, we want to improve. So if there is something that you don't like or that you see can be improved, never hesitate to tell us. And there is an exam at the end. It's an electronic exam in Inspera. It wasn't too bad last year. Like, student didn't hated us for it, so it should be okay. The course was quite hard. We were surprised because we thought the course was really simple. But it turned out last year that we were wrong, that the course for like 1/3 of the students was very seriously difficult. And for 2/3 it was kind of okay. And like 1/3 was like saying, oh, the course was easy, okay? So it depends where you will sit on that spectrum. It may be that the course looks hard for you, or it may seem that it is easy. But yeah, we was a little bit surprised that that the course was kind of hard for so many of the students. Okay, any other questions? Yeah?
Exactly where can we find that questionnaire?
So if you, so you cannot find it right now because you don't have the slides, right? I will put the URL to the slides on the wiki, and then you will find the questionnaire. You will find the video here and the questionnaire link here. Last year it was very trivial. I made a bit.ly shortcut so you could memorize it. But this year it's just a click, so you will have to click. So the only thing you have to memorize for now, which Christopher already emailed everybody from before, is that prod3.imt.hic.no. That's the only thing you have to memorize. Everything else will be on prod3. And once you register, you'll be added to the cloud course, and then you will see the lecture slides. Maybe I just email everybody where the lecture slides are after the class to make it easier for you guys. Yeah. Okay, any other questions? Okay, so thank you very much, and I will see you on Friday.